This is an enzyme. Enzymes are globular proteins that act as biological catalysts. Every enzyme has an active site to which a substrate binds. Enzymes are not changed or consumed in the reaction, so they can be used again. Enzymes are typically named after the molecules they react with. For example, amylase catalyzes amylose in starch. According to the induced fit theory, the enzyme's active site is not a completely rigid fit for the substrate. Instead, the active site will undergo conformational change when exposed to a substrate to improve binding. Here is amylase. It has an optimum pH of 7 and an optimum temperature of 32 to 37 degrees Celsius. The substrate is amylose, a main component of the polysaccharide starch found in many foods we eat. Here we have amylase and starch. This is the enzyme plus substrate stage. As they get closer, the substrate contacts the active site of the enzyme and we obtain an enzyme-substrate complex. The enzyme then undergoes a conformational change to fit the substrate. The enzyme catalyzes the substrate and we get an enzyme product complex. Finally, the products of the reaction are released. Starch is broken down into maltose molecules, which is a disaccharide made out of two glucose molecules connected by glycosidic bonds. Amylase then returns to its original shape. But what really happens during binding? The enzyme-substrate complex lowers the activation energy of the reaction and speeds it up. The active site depends on the location and distribution of polar and nonpolar amino acids, as hydrophobic and hydrophilic interactions can play a role in the substrate binding to the active site.